Everyone, welcome back to the Linux. Today we are going to see about multinomial naive Bayes algorithm. It is in a supervised machine learning algorithm and used for a classification task. And it's in a type of naive Bayes algorithm and used for a classification task. It it will works on the discrete data, like like strings, words, like that, and it assumes that each words in the each classes are multinomially distributed. This means that each word occupy in a specific dimensions. For example, if the number of words in the classes are 2, then it's occupy the 2 dimensions, like that. And multinomial naive Bayes algorithm works based on the Bayes theorem to find the probability of an input belongs to which classes. So first let us see Bayes theorem. This is a Bayes theorem and the equation looks like this. And this term called as conditional probability. If you see some probability writing like this, p of something x slash y, this will be written as probability of x given y. This means we are finding the probability of x, the already happened event y. So this event called as we are finding the class of the data x. If it's assumed that it is already happened, and it will find the probability like that. And the second term is p of x given y, sorry, x given c, and it will find the probability of an x given c, like in a hood, after finding the probability, and it will multiply with class probability, that is p of c, and divided by any p of x. Mostly the p of x is constant, so the equation will looks like this is the Bayes theorem equation. The p of x, it's in a constant, right? Because after training it, the number of words in the each classes it's constant. So the probability of an each word in the each classes it's also in a constant. So after finding the number of frequencies and words in the classes, the p of x will always be constant. So to reduce some, to reduce some calculation, we will remove this p of x. Due to removing this, to maintain the equation equality, we just remove this equation and put some proportional symbol, and this will work fine. It assumes that the free futures of a word occurrence. It assumes that futures are the word occurrence. Like in the Gaussian naive Bayes algorithms, it assumes that each futures or in each continuous values are considered as in a future, right? But in the multinomial naive Bayes algorithms, it considers the frequency of an occurrence, right? The frequency number of time the word will occurs. It considers that number as in a futures, and each words are independent, or we can say as each words are independent in each other in the each classes. To understand well, we will go some training process so that make you how the model will works. This is a probability formula for the each classes. For example, the count is total number of words in that classes, and total docs, like total number of words in the all the classes. This is a probability formula for n classes. If there is n classes, we find the n classes probability, and this is in a likelihood. The likelihoods are nothing but we find the probability of a data or a probability of word belongs to these classes, like that. We find the probability of each single word in the given message and find the probability of that word belongs to that class. After finding the probability, we we will find the probability using this. And the word count, it looks like if there is a word called x, then it will find the x number of times it occurs in that class, right? For example, there is a two classes and the given input is x, and it will find the x in the number of times the x occurs in the class one. For example, say the x occurs two times, then the count of w and class one is 2, and this is called this alpha symbol. Usually they consider as a 1, used for an smoothing. And total words in the class, if you find the number of times the x will occur in that class, then the probability will be number of words. you know the simple probability, right? If p of if n is in a total number or sample size, if you want to find the p of a in that n, it looks like p of a divided by p of n, right? This is the simple basic formula, right, for finding the probability. Here it's also same case, but in the numerator we add some alpha, and also denominator we add some alpha into a name, some vocabularies. I will tell you what is that later. In numerator, for a single word, it find the number of occurrence in that class, and after finding the occurrence, it will add some smoothing that is called alpha. And in the denominator, it will take the number of words in that class, the total number of words, okay, and it will add some vocabularies. The vocabularies are the number of words in overall classes, like in the entire data sets. That is called as W. Let's take this in a sample data set. Okay, we need to classify the data. They are given as there are two classes in a spam and another two classes in a not spam. We will train the model to separate these data. Usually, the multinomial naive Bayes algorithm works on discrete data, and we consider each word as in a discrete case, and we will the multinomial, you know, the multinomial naives will works on the frequency based, or we can say as count based, because we are finding the count, right? Count based. Based on the count, it will decide the probability of net data belongs to that classes, or we can say as probability of that word belongs to that classes in this case. First, what it will do was, let me erase this. First, there are two classes, right? First, it will take as a first class, spam class. It will just write all the words and its frequency. For example, in this case, by is occur one times, right? Sorry, two times. One, two. And steep. Steep is occur one times, right? And now is occur one times. And limited is one time. Limited is one time. And off is also one time. So the total number of words in this class is 6, right? Similarly, we do for a class 2. For a class 2, I just write here. For a not spam class, the number of words or meet is occurs one times, and me is occur one time. Now is also occur one time. Let's occurs one time, and catch also occur one times, and up also occur one times. Here is also the number of words in the not spam class also 6. So what is the total number of words in the both classes? You may think it's 12, but that's not the case. The total number of words in the overall classes, it's not 12, because in the total number of words, we don't consider the duplicates. Here it is, the by occurs two times, and now occurs two times, right? So in the total number of words in the all the data sets are doesn't have any duplicates. In this case, this is 1, 2, 3, 4, 5, by not consider, 6, 7, now not consider, 8, 9, 10. So the total number of words in this entire data set is 10. That is called as V, right? So let's move on to a next step. Now we find the frequencies and the number of words in the each classes, right? Now we want to find the probability of in a spam, like in general, if it is in a data, or we can say if it is in a some new input, what is the probability of in a spam class? For that, we will take in a entire data set and number of data are contains as a spam and number of data are labeled as in a not spam. Here it is, there are four classes, right? Sorry, there are four documents, right? And two of them are spam class and two of them are not spam class. There are equals, right? So there is an equal probability of in a data belongs to any each classes, right? So the formulas will be total number of words, sorry, number of spam class or number of spam message divided by a total number of text. Similarly, for a not spam class, like number of not spam message or not spam data divided by total number of message in the data. That is 2.0.5 and 0.5. As I told, the vocabulary is 10 words that are buy cheap now, limited offer, meet me, let's catch up. This name, like it's during the training process, we all find this, and after finding that, as I told, we do some, right. What do we find? Like we find the number of frequency of an each words for in both classes. It will do by year. Number of words like frequency in the spam class, and there are 6 words in the spam class, and V is 10, and alpha, as I told, usually it's taken as 1, and we find the probability for an word by, there are 6 words, right? Sorry, there are 5 words. For a word by, what is the probability if the data belongs to in a spam class? As I told before, the formula will be count of W, comma C plus alpha divided by number of words in the class plus V, the vocabulary. The count of word. Here the W is in a word, right? For here the by is W. So in the spam class, the number of times the by is occur is 2, right? 2. So the formula will looks like 2 plus the alpha value is 1, 2 plus 1 divided by number of words in the class. In this class, in the spam class, the total number of words is 6, right? 6 plus, and the V is total number of words in the entire data set, right? That is 10. It looks like 3 by 16, and the answer is 0.1875. We similarly do for an cheap class. Let's do that. Here the word is cheap, right? So the number of times the cheap is occur in the spam class, that is 1, right? 1 plus 1, this one is an alpha, divided by total number of words in that class 6, and total number of words in that entire data set is 10. It will be 2 by 16 and 1 by 8. It will be 0.125. And we similarly do for all data sets, like sorry, like now, limited, and offers. Similarly, we do all the probabilities. After finding the word count for a spam class, and we will do for a not spam class. Here it's also same as above. The formula is also same, that is count of W comma C plus alpha divided by number of words in the class plus alpha into the alpha is 1, so alpha into 1. In the not spam class, these are the words and respective frequencies. And if you find the probability, so I think all are same because all the frequency are 1, and total number of words in this case all are 6, and total number of words in the entire data set also 6, sorry, 10. So all its probability as 0. Let me do once. For an meet, the number of time the meet will occur in the not spam class is 1 plus alpha is 1 divided by total number of words in this class is 6 plus 10, right? That will be 2 by 16, right? And this answer will be 0.125. And similarly for an meet, it also occurs only one times in that class, so the same one will be there, and plus alpha divided by total number of words in that class plus vocabularies, like total number of words in the entire data set. And this probability also 0.125. In these cases, the all the words in this class will have the same probability. If there is a frequency mismatches, then the probability also mismatches. This is how first we will find the, like find the frequencies and update its probability in the during the training process, and store this probability in some parameters. While during the prediction, the user will give some input or message, right? That is buy now offer. It's like, no, we need to find it's in a spam or in a not spam message, right? And it's in a frequency, or buy it occurs one time, and now it occurs one time, and offer is also occurs one time. We what will we do was we take in a each inputs. Each are discrete, right? It's considered as a discrete and independent in each other, right? We take in a each inputs and pass to in a each classes in our dataset. For example, let's say that is buy me offer, right? That is buy is occur one time, and me is buy now. Sorry, buy now. Now is also occur one times, and offer also occurs one time. In this, multinomial distribution, each function or each word are considered to be in a discrete, right? So each word are passed to in each classes. It's like the pi of in a class 1, that is spam. The answer will be number of times the by occurs in the class 1. You know that the number of times the by is occur in the class 1 is 2. So the answer will be 2 plus 1. This one is alpha, and divided by total number of words in the class is 6, and our probability is 10. This will be 3 by 16. 3 by 16. We do some fractions later, and p of now slash spam. And here also the now is occurs only one time in the spam class, and that is 1 plus 1 divided by 6 plus 10, that is 2 by 16. And offer, p of offer divided by spam, that is the offer occurs one times, right? So 1 plus 1 divided by 6 plus 10, it's also 2 by 16. These are the probabilities of each inputs. In the first class, like spam class, we similarly pass this data into a not spam class. Like P of by in not spam class. Like by is occurs in one times, right? Let me see that. No, there is no occurrence of by, right? Me now catch. So there is no occurrence, right? So the occurrence is 0 plus 1 divided by 6 plus 10. That is 1 by 16. And we pass the second future, that is now plus in not spam class. And it occurs one time, 1 plus 1 divided by 6 plus 10 equal to 2 by 16. And similarly, we do for an offer class or offer future in not spam class. And offer will occurs, I think, 1. Mm, no, there is no offer occurs in this class, right? So it's 0. 0 plus 1 and 6 plus 10 equal to 1 by 16. So these are the probabilities: 3, 3 by 16, 2 by 16, 2 by 16. And you can see me, if you do 3 by 16, like by scam, right? 3 by 6, by and scam, right? Buy and scam. That is 3 by 16 and 16, 0 point, and we put 0, 6 ones are 16, balance 14, and 0, and 16 into 8, and 8s are 128, and goes on, right? So it's 1.8. This is a probability, right? You can do that division in yourself. And for an a buy in the scam class as in a probability of 0.1875. And similarly, now and spam, we already found that, that is 2 by 16, 2 by 16, and that is 1 by 8, and that is, that, like 1800, 1 times 8, and 2, 0, 2 are, and that is 16, 4, 0, 5 are 1 to 5. As you can see there, that is 1 to 5. And similarly, for an offer spam class, that's also 1 to 5. If you multiply them, and I forgot to tell one thing, we find the probability of a data belongs, entire message belongs to that class based on the bias theorem. The bias theorem looks like, let me erase this. The bias theorem looks like P of class into X equal to P of C into P of X given C divided by P of X. As I told, the X is constant, right? So to reduce some calculation, we simply remove this. We simply remove this. Due to removing, we simply remove this equal to and put some proportional symbol. And in this case, in this multinomial distribution or in a multinomial Navier Bayes algorithm, each word is considered as in a future, right? So we simply, in the given input, like offer, I don't know what's that. By now it's offer, right? That is by now offer. So each word it's considered as in a future in multinomial. So this equation will be written as C and X. X are considered as in a future, right? These are the discrete futures. So we simply write as by, comma now, comma offer. If you expand this equation, that is P of C into P of now, maybe you can write as by, you can write any order, doesn't matter, by class C into P of now class C into P of offer class C. This is a probability formula, right? For the number of users, we find the child likelihood. This is how we find the probability of a data. Here it is, we put as in a C, right? C. Here, this is called as classes. For the spam classes, we simply rewrite this. Let me P of spam and of these features. For an spam classes, we find the probability like this. These are C's are considered as this. In this case, the C's are equal to spam for an spam class. For a not spam class, we put the wherever we put the C, we use not spam and its probability. This is how we find the probability of a data that belongs to that classes. We find these are the probabilities and we know what formula we are using, and this is a probability of this data belongs to a spam classes. We similarly do for a not spam classes. We see like we find the probability for a not spam classes and we multiply them into a name, and we multiply with a name, that probability of a not spam classes, that is 0.5. After finding these are the probability, the which probability it's an higher, then the data belongs to that classes. Here it is, the this data is higher because there are 30, but here is 20 only, and it's considered to be a spam data or you can spam message. This is how we find the we train the model, and we will find the upon prediction upon new data like this, where it will applicable in real life, right? We use in a spam detection like we seen above, and text categorization and sentimental analysis of in a movies like that, and document classification. These are the application in the real worlds. And in summary, the multinomial naive base works well in the word counts, right? It will find the frequency, right? It will use this formula, right? Frequency formula, and use some naive Bayes algorithms, use some Bayes algorithms to find the probability. And it's faster and simpler and effective. It's find the frequency you already store in the during its training. Upon new data, it will simply find the probability of any data belongs each words in the each classes. And it's required the assumption of words are independent because the each word are independent and one word doesn't affect another's, and effective for many NLP problems. The many NLP problems, the natural language process are use these types of naive Bayes algorithm for text classifications and text generations like that. And that's it from this video. We will see you on next video. Thank you.